Assalamualaikum. We from Group 3 are going to present our project presentation where Group 3 consists of Noridina, Muhammad Idris, Afiq Saifillah and Abdul Hadi. So first, we are going to present our project overview. Starting with the problem background, we focus on two. First is environmental impact, where improper disposal of used cooking oil leads to clogged drains and fatbergs. Second, used cooking oil contaminates water bodies, where it harms aquatic system. So next, household challenges, where many households have lack of knowledge and means to store and recycle used cooking oil safely. Second, issues include unpleasant odors, risk of spills and handling hot oil. Next is the objective. First, on the design and prototype, we create a compact system for filtering and storing of used cooking oil. Second, we enable reuse of used cooking oil for biofuel and also soap making. Second is on automation and safety, where we integrate sensors and automation for safe and also clean handling of used cooking oil. So our proposed solution consists of these four main items. First is ultrasonic level sensing, where we monitor oil levels for efficient collection. Second is temperature monitoring, where it ensures safe handling of hot oil. Third is relay controlled pump, where we automate the transfer of oil. And fourth is the multi-stage filtration system, where it cleanses oil for safe reuse. Moving on to the V model. So now I will walk you through the structured development process that we followed for our smart used cooking oil recycling system. So first, let's focus on the user requirement. So our journey began at the very top with user requirement. So this critical initial phase involved our extensive research and also consultation to truly understand what our end users needed when dealing with used cooking oil. So we focus on ease of use, safety, efficiency, and also the core functionalities um, required to effectively collect, filter, and store used cooking oil in a domestic setting. So second is system requirement, where building on user requirement, we then translated this into concrete system requirement. So here we detail the specific functionalities, performance criteria, and constraints for the UCO recycling system. So this included defining the desired filtration level, storage capacity, operating modes, and also sensor specification. So third is the next came the high level design. So in this phase, we outlined the overall architecture of our used cooking oil recycling system. And then below the high level design, so following the high level plan, the detailed design phase took us deeper where every module and component of the UCO system was designed. So this includes selecting specific sensor models for UCO detection and also design the precise multi-stage filtration mechanism, specifying the pump's flow rate for efficient UCO transfer, and planning the user interface. So next at the very bottom of the V, we reach the implementation. So this is where the physical creation of the UCO recycling prototype happened. So based on our detailed design, we had assembled the hardware components, including the custom enclosure, the UCO collection funnel, the pump, the sensors, and also the filtration layers. Concurrently, we developed and uploaded the software to Arduino Uno, bringing our design to life as a functional UCO recycling unit. So right side, first step up, which is the unit testing. We tested individual components and modules of the UCO system in isolation. For example, we tested the ultrasonic sensor to ensure accurate UCO level reading, the temperature sensor for precise measurement, the pump's functionality in transferring used cooking oil, and the integrity of each filtration step. So above the unit testing, we have the integration testing. So where this combine different modules of UCO system and testing their interaction. So we test how the sensor communicate with the Arduino about UCO level, how the Arduino control the pump to initiate transfer, and how the filtration stage work together to process the used cooking oil. And then the above next was system testing, where the entire assembled UCO recycling prototype was tested as a complete unit. And then next is the user acceptance testing, often referred to as UAT. So this crucial phase involves potential end users interacting with the smart UCO system to ensure it met their initial need and expectation as defined in the user requirement phase. So their feedback was invaluable in confirming the system usability, convenience, and overall effectiveness. So in summary, the V model actually provides us with a structured and rigorous approach, where the left is the project definition, where we ensured that what we needed to build for UCO recycling. The right side, to ensure that we thoroughly verify and validate what we built and it is correct. So, and that it met users' true need. So, this systematic methodology was instrumental in developing an effective smart use cooking oil system. Next is the system requirement.
Okay, I will continue from here. So for the system requirement, first is our core functional component, the filtration model, which is filter out the food particle and debris from the used cooking oil. The second is storage tank, which is store the filter oil for the first tank, and the second is the filter cooking oil after the process. So next is small pump to move the oil between the filtration, and last is our microcontroller Arduino Uno to act as a central controller and reading the sensor data. Uh, for the second is the intelligent control and user interface. So our project is for design is easy automate use and focusing on convenience, safety and reliability for household. And is the important information like oil level, temperature and pump status also we include in our system and display in on the LCD display. And this model also run on a standard 5 volt DC adapter which power the Arduino sensor and display. A relay module is used to safely control the oil pump and provide an extra power while it separate from the rest of the system safely. Next, I will give it to the next presentation.
Thank you. Now I will proceed with the design development. Okay, so as you can see here, there is a three view of the prototype of this machine. So basically, we designed this prototype using CAD software, which is Fusion 360 provided by Autodesk. So by taking a look at the left design, which is the isometric view, at the top of the machine, we can see that there is a nozzle. So that is the unfiltered cooking oil will goes in there, and then it will goes to with the filtration process and end up in the storage tank, which will contain the uh, clean oil. And the center image is the front view of the prototype. So you can see that there is a switch for mode configuration, control knob, and the space for LCD chassis and also the status LED. And at the right side of the image, which is the back view of the prototype, so that is where the power jack power jack input is located, and the power button to turn on and off the machine. Okay, next I will pass on to Idris to continue.
So now I will present about the wiring diagram or the hardware component. So in this project, we implemented to use a few components. We divided into sensors, display, and also microcontroller. So in our system, in our design, we propose to use Arduino Uno and use two most important sensors, which are ultrasonic sensor and also the S18B20 for the temperature sensor. So these two are the main components in our circuits, and the display we use the 16 times 2 LCD display. Other than that, it's just we use transistor, LED and other components. So next. Okay, so for this part, which is I will explain about the coding. So briefly to present about coding part, I use the Arduino, Arduino IDE. So I include all the library needed in order to turn on all the sensors and connect to the Arduino Uno as our microcontroller. So each pin are being defined in the pin configurations. So we can see here all the line by line in order to explain and also to ensure the flow of the sensors and microcontroller is aligned with the certain value that we put. Next. So here are all the values that our team implements, such as percentage of oil level in the tank, the percentage. So what will be happen when the percentage is below 30%? What will happen if more than 99%? So this is all the coding that we implemented to show and prove during the simulation part. So the next. So for conclusion, so I think this project managed to introduce a smart domestic use cooking oil UCO recycling system. So this system basically is a solution that help to address the environmental and public health concerns with the improper use cooking oil disposal. So all of this project we managed to implement it. It senses its microcontroller well to in order to get the best result for the use cooking oil disposal. So I think that's all from me. Thank you. Assalamualaikum.